The primary purpose of a telephone system is to provide voice communication. It is the largest and most complex electronic communication system in the world. It is used for facsimile transmission and computer data transmission. The system is primarily used for voice, but it employs mostly digital techniques, not only in signal transmission but also in control operations. Although telephone system permits any telephone to connect to other telephones in the world, each telephone must have a unique identification code. A 10-digit telephone number is assigned to each. Standard telephones are connected to the telephone system by way of a two-wire twisted pair cable that terminates at the central office. These two-wire twisted pair cables are called local loops or subscriber loop. A complete circuit is formed from the telephone to the central office.
As shown in the figure, telephone A and telephone B are connected with the central office. This two-wire twisted pair connection between the telephone set and the central office is referred as the local loop or subscriber loop.
A telephone set is a baseband transceiver. A transceiver is an electronic unit that incorporates circuits that both send and receive signals. A telephone set contains a ringer and a dialing mechanism. Ringer is either a bell or an electronic oscillator connected to a speaker.
Switch hook is a double-pole mechanical switch that indicates when the phone is hung, often with a lever or magnetic button inside the cradle or base where a telephone handset resides. When the handset is on the cradle, the telephone is said to be on hook or ready for a call. When the handset is off the cradle, the telephone is said to be off hook or unable to receive any call.
Dialing circuits provide a way for entering the telephone number to be called. Telephones mostly use the dual-tone multi-frequency system. Dual-tone multi-frequency signaling is an in-band telecommunication signaling system using the voice frequency band over telephone lines between telephone equipment and other communication devices and switching centers. A handset contains a microphone for the transmitter and a speaker or receiver. The hybrid circuit is a special transformer used to convert signals from the four wires from the transmitter and receiver into a signal suitable for a single two-line pair to the local loop.
Usually, any telephone set will have following basic functions in the transmit and receive direction. In the transmit mode, indication to the user that call can or cannot be made by way of dial tones and busy tones respectively. In the receive mode, it should have ringer so that it rings the bell indicating that the call is received. Signal to the exchange that the call has been answered. Device to convert the voice to the electrical signal and vice versa. Such device is called as transducer.
Central office applies a negative 48 DC voltage over the twisted pair line to the telephone. When a subscriber picks up the telephone, the switch hook closes, connecting the circuitry to the telephone line. The frequency response of the local loop is approximately 300 to 3400 Hz. Telephone wires are usually color-coded. The tip wire is green and usually connected to the ground, and the ring wire is red. The ringer in most older telephones is an electromechanical bell. The ringing voltage supplied by the central office is a sine wave of approximately 90 voltage RMS at a frequency of about 20 Hz. In US telephones, the ringing voltage occurs for 1 second, followed by a 3-second interval.
The transmitter is the microphone into which you speak during a telephone call. In a standard telephone, this microphone uses a carbon element that effectively translates acoustical vibrations into resistance changes. The transmitter element is in series with the telephone circuit, which includes the 48-volt central office battery and the speaker in the remote handset.
The transmitter is the microphone into which you speak. As you can see, carbon elements are used to effectively translate acoustical vibrations into resistance changes. The transmitter element is in series with the telephone circuit, which includes the 48-volt central office battery and the speaker in the remote handset.
The receiver or earpiece is basically a small permanent magnet speaker. A diaphragm is physically attached to a coil which rests inside a permanent magnet. Whenever a voice signal comes down a telephone line, it develops a current in the receiver coil. The coil produces a magnet field that interacts with the permanent magnet field. The result is vibration of the diaphragm, which converts electrical energy into acoustic energy that supplies the voice to the ear.
The hybrid, sometimes called an induction coil, is a device composed of several transformers that is used to simultaneously transmit and receive on a single pair of wires. The windings on the transformer are connected so that signals produced by the transmitter are put on two-wire local loop but do not occur in the receiver and vice versa.
In practice, the hybrid windings permit a small amount of the voice signal to occur in the receiver. This provides a feedback called side tone to the speaker so that she or he may speak with normal volume.
Automatic voice level adjustment allows all the signal levels to be approximately the same regardless of the loop lengths of the two telephones connected to each other. All telephones contain this type of component. Rotary dialing mechanism produces a pulse dialing. A dialing system called touch tone uses pair of audio tones. This creates signals representing the number to be dialed.
Electronic telephones. Most multiple line and full feature telephones contain microprocessors. A built-in microprocessor permits automatic control of the telephone's functions and provides features such as telephone number storage and automatic dialing and redialing that are not possible in conventional telephones.
Most functions of an electronic telephone are implemented with circuits contained within a single IC. To provide accurate frequency reference for generating the dual dialing tones, an external crystal or ceramic resonator is provided.
A tone ringer is driven by the 20 Hz ringing signal from the phone line and drives a piezoelectric sound element. The IC contains a built-in line voltage regulator. An internal speech network contains a number of amplifiers and related circuits that fully duplicate the function of a hybrid in a standard telephone. A bridge rectifier provides a pulsating DC voltage. When the hook switch closes, the DC voltage is applied around an RC circuit.
Microcontroller contains the CPU, a ROM in which a control program is stored, a small amount of random access read-write memory, and input-output circuits. All modern electronic telephones contain a built-in microcontroller.
Functions performed by the microcomputer include operating keyboard, operating display, storing telephone numbers, automatic redialing, storing commonly called numbers, voicemail, and caller ID feature.
Voicemail, a feature previously called an answering machine, is implemented on most electronic phones. The microcontroller automatically answers a call after a reprogrammed number of rings and saves the voice message. In modern phones, the voice message is digitized and compressed and then stored in a small flash read-only memory ready for replay.
Caller ID, also known as the Calling Line Identification Service, is a feature that is now widely implemented in the most electronic telephones. With this feature, any calling number will be displayed on an LCD readout when the phone is ringing.
Most telephones are connected by way of a thin multi-wire cable to a wall jack. An RJ11 modular connector plugs into the matching wall jack. The wall jack is connected by wiring inside the walls to a central wiring point called the subscriber interface. It is also known as the wiring block or modular interface. The subscriber interface is a small plastic housing containing all the wiring that connects the line from the telephone company to all the telephone wires in the house. Cordless telephone is a full duplex, two-way radio system made up of two units, the portable unit or the handset and the base unit. The base unit is wired to the telephone line by way of a modular connector. It receives its power from the AC line. The base unit is a complete transceiver. It contains a transmitter that sends the received audio signal to the portable unit and receives signals transmitted by the portable unit and retransmits them on the telephone line.
The base unit contains a battery charger that rejuvenates the battery in the handheld unit. The portable unit is also a battery-powered transceiver. Both units have an antenna. The transceivers in both the portable and the base units use full duplex operation.
The base unit contains a battery charger that rejuvenates the battery in the handheld unit. This battery charger is connected to the power supply of the base station, which is connected to the AC line. Both the station and the handheld unit has an antenna. The line interface is connected to the station's antenna that receives and transmits signals. The antenna of the handheld unit is connected to the speaker as the receiver and the microphone as the transmitting signal. Both have microcontrollers that has a keyboard and display.
The FCC has set aside four primary frequency bands for cordless telephones: 43 to 50 MHz, 902 to 928 MHz, 2.4 to 2.45 GHz, and 5.8 GHz. The phones are programmed to automatically seek a channel pair with no activity and minimum noise.
The telephone system refers to the organization and facilities involved in connecting a telephone to another telephone anywhere in the world.
The subscriber interface or the subscriber line interface circuit or SLIC is comprised of a group of basic circuits that power the telephone and provide all the basic functions. Most functions of the SLIC are implemented by one or two ICs plus supporting equipment. Seven basic functions of SLIC are battery, over voltage protection, ringing, supervision, coding, hybrid, and test. Whenever you make a telephone call, your voice is connected through your local exchange to the telephone system. From there, it passes through at least one other local exchange, which is connected to the telephone you are calling. Several other facilities may provide switching, multiplexing, and other services required to transmit your voice. The telephone system is referred to as the Public Switched Telephone Network or PSTN.
Central office or local exchange is the facility to which your telephone is directly connected by a twisted pair cable. Regional Bell operating companies, also called local exchange carriers, provide local telephone service. The LECs provide telephone service to designated
Long-distance service is provided by long-distance carriers, known as inter-exchange carriers. The IXCs are the familiar long-distance carriers such as AT&T, WorldCom, and US Sprint. Long-distance carriers must be used for the interconnection for any inter-LATA connections. Private telephone systems implement telephone service among the telephones in a company or organization and provide one or more local loop connections to the central office. The two basic types of private telephone systems are known as key systems and private branch exchanges.
key systems are small telephone systems designed to serve 2 to 50 user telephones. These telephone systems are made up of individual telephone units called stations, all of which are connected to a central answering station. This station is connected to more local loop lines or trunks. Telephone sets in a key system typically have a group of push buttons that allow each phone to select two or more outgoing trunking lines.
Private branch exchange is a private telephone system for larger organizations. A small replica of a telephone exchange installed at subscribers' premises and connected via trunk lines. Depending on its capacity, a PBX can handle tens or hundreds of telephone lines and reroute the incoming calls to the appropriate extension automatically or through an operator.
Modern PBXs are built around a small computer and some of them can be connected to a server for additional services such as call management, call detail reports, and telemarketing. It is also called Private Automatic Branch Exchange or PABX. Centrex is an alternative to PBX. This service performs the function of a PBX but uses special equipment and special trunk lines. Family, also known as fax, is an electronic system for transmitting graphic information by wire or radio. It is used to send printed materials by scanning it and converting it into electronic signals that modulate a carrier to be transmitted over the telephone lines.
With facsimile, documents such as letters, photographs, line drawings, or any printed information can be converted into an electrical signal and transmitted. Facsimile uses scanning techniques that are similar to those used in TV. A scanning process is used to break a printed document up into many horizontal scan lines which can be transmitted and reproduced serially.
Simile system has a fax machine that scans and prints a document. It also has an internal modem that modulates a carrier set to the middle of the telephone voice spectrum bandwidth, and the modem also demodulates the signal. The data is then compressed and printed out.
Digital transmission with standard modem techniques is used in today's modern fax machine. It is also a high-tech electro-optical machine. Scanning is done electronically and the scanned signal is converted into a binary signal.
Transmission process begins with an image scanner that converts the document into hundreds of horizontal scan lines. They all incorporate a photo light sensitive device to convert light variation along one scanned line into an electric voltage. The resulting signal is then processed in various ways to make the data smaller and faster to transmit.
The signal is sent to a modem where it modulates a carrier set to the middle of the telephone voice spectrum bandwidth and then transmitted to the receiving fax machine over the public switch telephone network. The receiving machine's modem demodulates the signal that is then processed to recover the original data. The data is decompressed and printed out. Most fax machines use charge-coupled devices or CCD for scanning. A CCD is a light-sensitive semiconductor device that converts varying light amplitudes into an electrical signal. Data compression is a digital data processing that looks for redundancy in the transmitted signal.
Paging is a radio communication system designed to signal individuals wherever they may be. Paging systems operate in a simplex mode or one way. To contact an individual with a pager, make a telephone call. A paging company will send a radio signal that will be received by the pager.
The newest pagers are two-way devices that receive data or send data in the form of numerically coded messages or short alphanumeric text.
Paging business is closely allied with the telephone business because the telephone system provides the initial and final communication process. To page a person, an individual dials a telephone number assigned to that person. The call is received at the office of the paging company. The paging company responds with one or more signaling tones that tell the caller to enter the telephone number the paged person should call. Once the number is entered, the caller presses the pound sign key to signal the end of the telephone entry.
The paging system records the telephone number in a computer and translates this number into a serial binary coded message. The message is transmitted as a data bit stream to the paging receiver. Paging systems usually operate in very high frequencies, 30 to 300 MHz, and in ultra high frequencies, 300 to 3000 MHz. Most paging systems can locate an individual within a 30-mile radius.
Caller dials a pager phone number. The call reaches a paging terminal over telephone company lines. The paging terminal is linked to numerous transmitters through the paging coverage area. When it receives a message, the terminal converts the message into a pager code and relays this code to the transmitters. The transmitters send out the code through the entire coverage area. The code is picked up by all of the pagers within the coverage area on that particular frequency, but only the pager with the proper code is alerted and will display the message.
Each paging receiver is assigned a special code, also known as a cap code, which is a sequence of numbers. The cap code is broadcast over a paging region, and if the pager is in the region, it will pick up and recognize its unique code. Flex system is the most widely used digital paging format. Reflex and inflection are two waveforms of flex.
Paging receiver is a small battery-powered super heterodyne receiver. It uses a single-chip IC receiver. Most basic paging systems use some form of the frequency modulation. Internet Protocol or Voice over Internet Protocol uses the Internet to carry digital voice telephone calls. It almost bypasses the existing telephone system and it is a highly complex digital voice system. It relies on high-speed internet connection from cable to TV companies.
Voice over Internet Protocol uses vast fiber optic cabling network to carry phone calls. In large companies, Voice over Internet Protocol is replacing traditional telephone service because it offers the benefits of lower long-distance calling charges and it reduces the amount of new equipment needed.
Basic parts to an IP phone call, the dialing process and the voice signal flow.
The voice signal is first amplified and digitized by an analog to digital converter, which is part of a codec circuit that also includes a digital to analog converter. The bit stream is processed by a voice encoder that compresses the voice signal. The resulting serial digital signal is put into a special packet by a microcomputer processor running a voice over Internet protocol and then transmitted by Ethernet.
There, the signal travels over standard available internet connections using TCP or IP through multiple servers and routers until it comes to the desired location. At the receiving phone, the process is reversed. The internet signal gets converted back to the internet and the VoIP processor recovers the original packet. The compressed data is extracted, decompressed by a DSP, and sent to the DAC in the codec where the original voice is heard.
One of the main problems with voice over Internet protocol is that it takes a relatively long time to transmit the voice data over the Internet. Also, even though the signals travel at gigabit speeds, the packets pass through numerous routers and servers, each adding transit time or latency. Latency refers to the delay between the time the signal is transmitted and the time it is received. One party may have to wait a short time before responding to avoid talking while the signal is still being received.
IP or Session Initiation Protocol is used to get the packetized voice data to the desired phone. The protocol sets up the call and then makes sure that the voice produced gets sent to the receiving phone.
To establish IP phone service in the home, the subscriber must have some form of high-speed internet service. In addition, the subscriber must have a voice over Internet protocol interface. A common example is the analog terminal adapter. This device connects the standard home telephone to the existing broadband Internet modem.
IP phones in companies or large organizations are especially designed for voltage over Internet protocol service. The telephone set contains all the ATA circuitry except for the SLIC and connects directly to the available Ethernet connection. No broadband modem is needed. Since most employees will also have a PC connected to the LAN, a two-port Ethernet switch in the phone or PC provides a single Ethernet connection to the LAN that the phone and PC